Okay, so hi, I'm Rahul, and I welcome you all to today's webinar organized by Genisync on 2D and lighter integrated antennas for unmanned aerial vehicles industries. So let's start this webinar with a short introduction of Genisync. Genisync was created in 2010, employing about 22 people as of today. We are specialized in producing nanometals and formulating them into inks for various printing processes. We have been granted over 10 patent families and have a manufacturing unit with a capacity to produce up to 1 ton of nanoinks per year. Our headquarters are based in south of France with sales offices in Paris, Tokyo, and Taiwan. And for the North American region, we have 2 distributors in place who represent Genisync out there. So what makes Genisync unique in the consumer electronic industry is our ability to produce ourselves the nanoparticles, that is mostly silver, and then formulating them into inks that are adapted into each printing processes. Today, we have more than 40 different formulations, and our R&D team is split into 3 main areas. That is material scientist for manufacturing of the nanoparticles. Then we have chemical engineers for the formulation of the inks. And finally, we have printing and electronic engineers for fine-tuning and to support the electronic printed and the electronic industries. We also have in-screen screen printing, digital printing, and spray coating equipments. And we work together with the global key players in the printed electronic industry to test and qualify our inks. So today's webinar will be presented by Benjamin and myself. I'd also like to take this opportunity to quickly introduce the R&D and customer support team. We have Rita Fadul and Benjamin Duesh, our 2 R&D project managers at Genisync. They both are engineers and have a PhD in chemistry and printed electronics. In the customer team, you have Raul Ashok, that's me, the business development manager at Genisync. I come solely from a management background, and I handle the accounts mainly from Europe, Middle East, and the Indian subcontinent. Then we have Greg Wastalens, a technical applications engineer. He's an electronic engineer and as well a printing expert. So let's have a look at the agenda for today's webinar. So I will be starting off with by giving you a brief introduction of on connected UAVs and drones. Following that, I'll be quickly talking about the market and the uses and applications and so on. And following that, Benjamin, my colleague, will take forward, and he will be talking more on Genisync solutions for integrated 2D antennas in UAVs. And finally, we will end today with the question and answer session, and also with a couple of polls which will be sent out to you a little later. So what is a drone or a UAV? UAV are a class of aircraft that can fly without the onboard presence of pilots. Unmanned aircraft systems consist of aircraft components, communication systems, and a ground control station. They can be controlled by control equipment from the ground. So now let's have a look at the different UAV components. A UAV consists of many components and technologies. The technology related to the drones are constantly evolving as the innovation rises. A typical drone is made of light composite materials to reduce weight and to increase flexibility. Since drones cannot carry human operators or let's say pilots, the body of a drone typically contains the technology itself. Drone technology refers to everything from the aerodynamics of the drone, materials in the manufacture of a physical drone, to let's say circuit boards, chipsets, software, and communication systems. But of course, today I will not be talking about each and every component that's present in a drone, but rather focusing on those components that can be done via printed electronics. So to start off with, we have power supply and platform. So the small UAVs mostly use lithium polymer batteries, while the larger ones require conventional airplane engines or hydrogen fuel cell. And for satellite positioning, we have GNSS antennas that are used to aid in drone navigation. We also have the Bluetooth, Wi-Fi, or cellular networks like 4G or 5G antennas to guide the drone using a smartphone. Drones also consist a sensor which can be used to create 3D models of buildings, landscapes, etc., to collect and provide precision data to users. Then next would be LED flight indicators that allows the operators or pilots to know the orientation of the drone. And finally, we have UAV actuators, including digital electronic speed controllers that is linked to the engine and payload actuators. So actuators contains hybrid PCBs, which with part of it that can be printed, which will be explained at later stages by my colleague Benjamin. So now let's have a look at some of the uses and applications of drones. Drone technology as of today is used for commercial, industrial, as well as military purposes. So starting off with military, military usage of drones has become a primary use in today's world. They are mainly used for combat missions and for supervision. And for commercial usage of drones is starting to gain momentum at the moment and has become the talk of the hour as various industries are beginning to work with drones as part of their daily regular business functions. And we also have UAVs that is used in agriculture. It is mainly used to help optimize agriculture operations, to increase crop production, and to monitor growth. Sensors and digital imaging capabilities can give farmers a richer picture of their fields. And when it comes to construction industry, we also have drones that are being used over there, mainly for surveying or for inspection purposes. Drones are equipped with downward-facing sensors, and they can capture a great deal of aerial data in a short period of time. And when it comes to the energy industries, drones provide safe, efficient inspections for the energy industry, that is, including traditional power generation and transmission and distribution. Then, when it comes to security, there's so much that a drone can do to strengthen security. So they're being used to look at perimeters and to conduct surveillance over larger areas. And yes, so drone is also used to transport packages, food, or other goods. We see companies like Amazon that have started to implement uh, drone delivery, which can deliver packages within less than 30 minutes or less. And as you might have already seen, we have many of them that own drones today for recreational or entertainment purposes, such as to shoot aerial views of an event or to gather beautiful photos and videos. And finally, drones are also used for weather forecasting. That is, when you have a storm drone flying through different parts of the atmosphere to gather different types of data, it will, let's say, enable meteorologists to predict weather conditions for the coming weeks. So now moving on to the market. So yes, between 2016 and 2020, it was forecasted to have a 100 billion market opportunity for drones, helped by growing demand from the commercial and civil government sectors. So as you can see in the pie chart or in the presentation, we see that the drone market, the majority of the drone market is mainly in the military sector, followed by the consumer sector with 17 billion US dollars, and finally with 13 billion US dollars with the commercial and government sector. So yes, as you could see on the slide, UAS technology market forecasted at 41 to 114 billion dollars globally in 5+ years time. Well, US being the biggest market in the world with over 29% market share, followed by China with over 23%, and then we have Europe, India, and so on. So what is the takeaway from all this? With the evolution of regulations, we see drones headed for new heights in the business world. The $100 billion market opportunity, which we forecast over the next 5 years, is just the tip of the iceberg. So drones' full economic potential is likely to multiple times that number as the ripple effect resonates throughout the economy. So finally, let's have a look at some of the key market players in the drone industry. To start off with the military UAVs, manufacturers of military UAVs. Some of the big players in the market are Boeing, Dassault Aviation, Textron, and General Atomics. And when it comes to, let's say, commercial UAVs, we have big players such as Samsung, Ericsson, Huawei, Qualcomm, Airbus, Nokia, Parrot, etc. So, yes, my colleague Benjamin will take forward from here, where he's going to present to you the different genusing solutions for the antenna application in UAVs.
Thank you, Raoul, for this very nice introduction about UAV and its market. I will now present you the genusing solutions that we can offer to you in the field of these UAV industries. First of all, smart innovative electronic devices are nowadays mostly hybrid and flexible. They are combining, in fact, two different technologies. The first one is potentially printed flexible components like conductive interconnect antennas, solar cells for energy storage, display, communication interface and thin film batteries. And the second one is more traditional manufacturing to make processors and memories. Genusing actually proposes many solutions as conductive and semiconductive inks for the first technologies to solve technological issues about reducing form factor, increasing fineness, and electrical performance in consumer electronic applications. Integrated electronics display many advantages, such as low weight. The integration of antennas directly into miniaturized 2D systems without external cables contributes to hugely reduce the weight of the consumer electronics. Another advantage would be in the highly automated manufacturing on demand of these fully customized components, with reducing waste material output and using environmentally friendly processes. With our technology, we can even more integrate electronics onto flexible materials for better suitability in the entire system. As Raoul mentioned earlier, our range of conductive and semiconductive inks is suitable for the overall conception of the electronic circuitry or PCB or hybrid PCB as presented on this picture. In fact, smart ink, which is a conductive ink based on silver nanoparticles, can intervene in the manufacturing of integrated antennas, conductive interconnects, and communication interface, for instance, while Helios ink, a semiconductive ink based on metal oxide nanoparticles, and conductive based on silver nanowires, are completely beneficial to the manufacturing of display, photodiodes, and solar cells for energy storage components. Other solutions are also available at Genusync in the research and development phase and ready for beta testing. The first one concerns integrated antennas based on silver nanoparticles technology for aeronautics and UAV applications. It was a research and development project funded by the French Defense Procurement Agency and ended last year. We developed conductive high silver loaded inks suitable for screen printed and spray deposition methods and adapted to various composite substrates. We were able to tune the thickness of the conductive layer of the integrated antennas using one or several passes to reach the best performance in terms of conductivity, adhesion, and radio frequency, even for 5G. With excellent reliability in different standard environmental conditions, for example, they passed climatic, mechanic, and vibration tests. During this project, cellular phone and GPS tracking antennas demonstrators were realized in partnership with Cobham Antennas, Airbus Helicopter, and IM2NP Laboratory, with showing very good performance. A second solution, agenesing for the integrated UAV antennas, is our patented technology of copper metallization that was developed in collaboration with the CEA French agency. Two research and development projects were funded respectively by ANR and ADEME Région PACA. An eco-friendly process was developed with reducing by a factor of 10 to 50 the key environmental indicators like global warming, ozone depletion, terrestrial acidification, water eutrophication, and so on, compared to the traditional metallization methods, which is most of them subtractive. With this additive process of substrate metallization based on an electroless bath technology, we can manufacture local and full layer copper metallization beneficial to antennas and lightning protection. Thanks to this more eco-friendly technology, we can reach very high performance on many different types of substrates, such as composites, PET, PVC, ABS, and Kevlar materials. We can tailor the thickness of the copper layer from 0.25 to 2 micron, while we keep the electrical resistivity down to 5 micron centimeter and the adhesion up to 5 V. Full metallized surface demonstrator have been realized and tested for lightning protection by our industrial partner in aeronautics, showing very good performance against lightning without any degradation or delamination observed. One of the big advantages of this technology is the reduction of the copper coating weight by a factor of 20 compared to the other lightning protected coatings, meaning that with this technology, we were able to reduce considerably the weight of the coating for the lightning protection. And as you can see on the different pictures on this slide, we can also manufacture copper metallized surface locally by using different inject, printed, and spray methods. So to conclude with this webinar, GeneSync nanoinks and materials show enhanced properties and are adapted for all types of electronic substrate and applications with using our three ranges of products. Silver-based smart ink is beneficial for conductive interconnects and printed antennas. Metal oxide-based Helios ink is useful for electron transport layer and all transport layers in OLED devices and displays. And finally, silver nanowires-based conductive ink is designed for transparent conductive electrodes in energy storage solar cells, OLED, and displays as perfect alternative to replace ITO.
So yes, that's about it. This is where we come to an end. Before we move to the question and answer session, we have a couple of polls which will be sent out to you right now, which should help us to have your feedback and improve on the upcoming webinars. So we have around, let's say, 5 questions. If you could help us answer it, we would really appreciate it. So the first question is, how interesting was the webinar from a scale of 0 to 5? Well, 5 being very good, 0 being very bad.
We will give you a few seconds to answer this question before moving on to the next one.
Okay, we could move on to the next question. The next question would be, would you be interested by, and we have given you a different options. Okay, moving on. So the next question would be, by which range of Genesinks products are you interested? Just to give you a heads up again, the Smart Ink range is based on silver nanoparticles. The Helios range are the semiconductor inks, and the conductive range is a transparent conductive ink solution. Okay, so moving on. The next question. What are your sectors of interest?
Multiple choices are possible.
Yes. Okay, perfect. The last question. Would you like to receive a copy of the webinar's presentation? It's quite simple.
Okay, great.
Yeah. So moving on to the question and answer session. Feel free to type out your questions in the small box, the Q&A box on the left-hand side. As of now, we have two questions. The first question would be, could you share your presentation with the attendees? Of course, we shall share it with you all later. What level of cleaning do you need to ensure on your surface for deposition? And what is the separation that you ensure to avoid short-circuiting of the antennas?
Yes, regarding, thank you for this question. Regarding the cleaning and to protect the conductive layer deposited on the different substrate, we actually sell with our range of conductive products, Smart Ink. We are selling also another ink, which is Protect Ink. We will ensure you to avoid this kind of shortcut and to protect the ink from scratch or any degradation. So we have a solution to clean also, and to clean the different printer you can use to print the inks, and also to protect the ink. So two solutions: cleaning ink and protect ink.
Okay, thank you, Benjamin. The third question for today is, what's the maximum power you can put on the tracks? Let's say, for example, 1 millimeter width, for example.
Okay. For this question, I maybe would need more details of what you are requesting. For the 1 meter width, for example, the maximum power, it depends on what you are looking at. Maybe from this question, I will be pleased to answer and to discuss with you later on, to discuss what you are meaning about this question.
Yes, we could get back to you with more precision by email. Okay, so next question. Do you have experience with carbon black in conductive ink, and how successful does carbon black pigments expect the final properties in comparison to silver used inks?
Actually, we don't have so much experience with carbon black because we are selling metal-based nanoparticles ink formulations. So we are more familiar with silver, but we also did comparison with the different carbon black we can see on the market, and we kind of benchmark our inks to see what are the performance of our ink. And yes, of course, silver-based inks are are more have more performance and are the better than compared to carbon black. Um, we um, we have some very high performance in terms of conductivity, and also if you want to use silver-based ink, it's really to solve technological issues regarding the reduce regarding the decrease in terms of form factor of your design, and also to the fineness of the lines. So I mean that if you want less width line, less width tracks, to keep while you want to keep the electrical performance at the highest as possible.
Okay. What curing temperatures are needed for a typical silver ink? Well, I can answer this. Our inks are low temperature sintered inks, meaning you could start sintering by, let's say, 60 degrees Celsius, and you could go up to 150 or 200. And I would like to bring to your attention, at 60 degrees Celsius, we are able to achieve very high conductivity already at such low temperatures. Okay. So next question. Are you considering developing biodegradable inks in your product line in the future?
Yes, this is something we are looking at the moment. We actually have other research and development projects. We were able to print on paper substrate we developed a bio-based conductive ink in other collaborative projects to print on paper. So yes, this is something we are looking at, and yes, we are doing in the several collaborative projects some life cycle analysis to improve the eco-friendly status of the process and the different technologies we have in house.
Okay. Are there any suggestions for printing on high performance materials like PEEK?
PEEK. Yes, this is something we can. We already printed some different inks that works well on PEEK. So this is something we can. This is something we can do on this kind of substrate. After that, it will depend on the different requirements you are needed to. You are looking at for the different specification on that.
Okay. So the next question. Sorry, what just happened? Just a moment. There's a small.
I can see if you want.
Yeah. Do you see the questions? Okay. Besides inkjet, are your inks compatible with 3D printing of structures with embedded antennas? Yes. Besides inkjet, we of course have inks, other digital printing inks for aerosol jet, which can be 3D printed. Okay.
Maybe the last question.
Yes. And of course, we also do have inks based on syringe coating, which can be used for 3D printed electronics as well. Okay. I mean the ink based on silver nanowires? No,
yes. Do you need an overcoat layer on top of the conductive inks of Genesing to fabricate transparent conductive ink? I guess you mean, yes, this is the same person, the ink based on silver nanowire. No, we don't need this. We don't need an overcoat or a top coat layer on top of the transparent conductive ink to make it transparent. we obtain more than 90% of transparency of the coating layer on a different kind of substrate. It could be PET, PC, and so on, with A's that could be low, depending on. This is a kind of compromise between the conductivity and the A's, if you are looking at this parameter as well. But we don't need this kind of top coat to make the film transparent.
Okay, so we're running out of time now, and I'm afraid that we'll have to call it off here. If at all there are any unanswered questions, we shall get back to you soon by email and get in contact with you. All right, we thank you all to have attended today's webinar, and we hope that it was informative to you all.
Thank you all for your time. Have a good day.
Have a good day. Bye-bye.